Kinda. So domain of a function, what is it?
X value?
Values of x for which the function makes sense.
Good. X values that make sense. What does not make sense mean?
The one that isn't covered by the function line.
Isn't covered by the function. I like that. Covered. That's good.
Does that mean that is that the one that there's more than one solution, or there's
Set. I'm gonna give you a hint here. Set of all.
Set of all numbers.
It's not always all numbers.
It's not-
True. So what I'm going to clarify this for you guys. It's the set of all input values. And it means it's the set of all things you're allowed to plug into the function, which means we need to know what are we not allowed to plug in. What makes us sad when we plug things in? What are we not allowed to do with functions? What's one illegal, quote unquote, illegal operation? Raise your hand. Someone tell me. What's one illegal? We're using our hands. I can't hear you unless I call on you. Yeah. You can't, with real numbers, you can't do what? You can't take the square root of. Okay, that makes a frowny face, right? We don't like negative radicans. And we don't like this. We don't like dividing by 0. So we want to avoid this. We want to avoid these two things. It's everything besides those two things. It's all the values that don't result in that. So what's the first one? That first one was f of x equals 9 over x minus 4.
So now x minus 4 has to be anything but 0.
X minus 4 cannot be 0. So x cannot be 4. The better way to say that for domain is you can do it two ways. Write a sentence. X can be all real numbers except 4. You could write that out. The shorter way to write that, mathematicians like to summarize, they like to distill. X such that x does not equal 4. How many people have seen something like that before? It might be new. Some people might have seen it. This means the set of all numbers such that x does not equal 4. In this case, all real numbers. That bar means such that. So with this in mind, with these two things in mind, do you think you'd have a pretty good jump on doing the next two? Try that tonight. So what are you trying to find out? What numbers make the denominator 0? And what numbers make the thing underneath the square root negative? So don't answer that now.
That's the solution?
That's done. This is the answer to the first one. That's it. Or you could write a sentence. All real numbers except 4. If you're ever confused about how to write it, write a sentence, everybody. Sentences are great.
You give points for sentences?
Absolutely. Sometimes it's much easier to write a sentence. Sometimes it's harder. Whatever one has worked, that's fine. Sentences are fine. Okay, let's use our hands. We're using our hands. We're going to raise our hands. Which one do we want to see?
Can I just ask a question about what we just did?
Yes.
The F just the G and the H all mean the same thing, right?
They're just different functions. I could have called them Bob,
Okay.
Sarah, Alice, anything. Horsey, pony, anything. F, G, and H are just names. What's your name again? Andy. Number 1. Did anybody find the nice, clean way to find the area of this triangle? Anybody find a clean, easy way? No? Well, it gives you 3 coordinates, right? It gives you 1, 2, gives you 6, 3, and it gives you 4, 5, right? So you have this triangle. What's the traditional way you guys have found the areas of triangles? What formula have you used? Let's use a hand. Yeah, we traditionally use 1/2 base times height, right? How many people tried to use this? It's kind of hard.
Yeah.
It's hard because you can find the base, but what's really hard to find? This triangle is not a what? It's not a right triangle. So finding the height is hard because you need an altitude. The altitude is perpendicular right here. You have to find the intersection point and distances. I'll tell you what the answer to this. It's 6. It comes out to 6. Kind of cool, huh? But if you use 1/2 base times height, it's really challenging to get to 6. There's a different way, and I'm going to give you one hint. And this is as far as I'm going to go, and you guys can go from there. I'm going to draw a really bad rectangle. That's a rectangle, okay? How many, I'm going to stop after asking you these questions. How many triangles do you see?
4.
That's all I'm going to give you.
Let me guess.
Okay? No guessing. You're going to work on this tonight, okay? There's this. Is this a little easier to work with now? Yeah, that's all I'm going to give you. Clicks, huh? Okay, using hands. We're using hands. Brooke.
5.
Ooh, 5. These are the popular ones. These have come up in the other classes. So this ball is traveling, right? What type of function is this? Someone just shout it out. What type of function? Quadratic. Can someone just shout out one thing you know about this quadratic?
It's gonna go like lost.
So opens down.
Opens down. Bloop. Yeah, bloop. Opens down, okay?
Should have a line of symmetry.
Yep, it has a line of symmetry. Very good. What's the y-intercept of this function?
5.
What's the logical beginning time of this function? Yeah, most logical problems with time equals 0 is the beginning. This thing goes up and it goes down. The first part of this question asks for the max what?
Height.
Where is the max height going to occur?
Vertex.
Vertex, which is right up here. The second part of this question asks for when does it what?
Hit the ground.
Hit the ground. What's a way to say that point?
That's a positive x-intercept.
The positive x-intercept. There's the x-axis. The x-intercept is going to be right there. What's another word for x-intercept that you've heard before? The 0. Yeah, when you say 0, it's kind of a bland word to use for something very specific, right? We don't have an equivalent word for y-intercept, just 'cause. How do we traditionally find x-intercepts? What's the nicest way to find x-intercepts? You hope it does this. You hope
Count
Y
it.
instead of Y. So 0 instead of Y.
0. Okay, yeah, you solve 0. You solve it. Y equals 0. But then, what's the methodology that you like the most? The cleanest?
Counting the boxes.
Counting the boxes. But what are you trying to do? You set it equal to 0. What's your favorite method of solving quadratics?
Quadratic formula.
That always works, but it's not always the easiest. What's the easiest one usually?
Fraction.
Factoring. So you have to ask yourself, is this factorable? Is this factorable? It's kind of a trick question. Everything is factorable. The question is this factorable nicely? It's not. This is a tease. It looks like it might be. You test it out, and what happens? No. So since it's not factorable, what do you have to do? Quadratic formula. Now here's the thing. If you use the quadratic formula on this, you will end up with the square root of 6,670 as part of your answer. Do I expect you to simplify that without a calculator? No. Stop. Your answer is going to be something plus or minus the square root of 6,720 over something else. That's two answers. You want one, so you want to eliminate one of them.
The negatives.
The negative one, the one that's negative, because you don't want to have negative time, right? Because one of these is going to be negative, right? Stop there. Now, we're going to go back to vertex. What do you need to remember to find the vertex? There's two ways to find the vertex. What's the easiest way that you might remember? Use a hand on this one. There's a value. Yeah. Negative b over 2a. The vertex, do you remember these? Vertex is hk. Sometimes you see it written like that.
Yeah.
And h is equal to negative b over 2a. Is that familiar to anybody in here? Who's kinda? Here's the a value. Here's the b value. Here's the... So the x coordinate of the vertex is going to be negative 80 over... ...40 over... negative b over 2a. This is how I do fractions. Bear with me. 10 over 8, which is?
Shouldn't it be negative?
No.
But you started dropping things. Oh, that's right. Never mind.
So negative 5, 4. So we have the x coordinate. Is that what the question's asking you for?
No.
It's asking you for the height. The x coordinate represents... Did I do some math wrong?
Then you put
I don't know, but you put 2 negative 32 and then 1 from there.
Negative b over 2a.
And
should be
An A.
Oh, yeah. Yeah. It should be negative what? 16. I did the math in my head and then wrote it anyway. Thank you. That's part of your job right there, is to catch errors like that. Thank you. So what does it come out to be? It's 5 over 2. So that's the time. No, it's 5 over... It's positive. So that's the time, right?
That's when we did so
So you have to do h of... And what does it come out to be? Did anybody get it?
105.
We got the time at which... That's the time it hits the vertex.
Okay.
But is that the maximum height?
No.
No, what is it? It's
That's
that's
the
the
time.
coordinate.
That's the x coordinate. So you need the
Y value.
y value, and it comes out to be, I'll just tell you, 105. It's a little annoying. You plug 5 over 2 into the original equation right there.
Okay.
You plug it into this. Is that cool? So you have an idea of what to do on this? Now, the one other thing you could investigate if you want to, this is helpful to remember. Does this ring any bells when you see it? Has anybody seen that before? Maybe you have. Maybe. Does anybody know what it's called? HK is vertex. This is called vertex form. You can also attack this problem by using vertex form, by doing something you may have heard, which is one of my favorite things in the world, but you'll hate it. It's okay. Completing. Yeah. How do you say that in French?
I don't know. I didn't.
Oh, you could have made something up, and I would have gone with it. You could just go with it next time. This is how you get to teach me bad French, okay? It's not like I know any good French, so. You've seen completing the square? We're going to use that. Has anybody proven the quadratic equation to you? Shown why the quadratic works?
Yeah.
When you prove the quadratic equation, you have to complete the square. Are there any last things you want hints on? Like you have no idea where to go. Brooke.
I just have a question on the way something is paid.
Sure. What number?
The last page, 9.
Ah, on page 9. What is that? Can someone just tell me what that is?
Page 9.
Oh, I have no idea.
No, number 9. It's a piecewise. It's a system. Now here's the thing. What's your question, Brooke?
Or there's 6 different equations.
No, there are 3. And so those are 3 equations,
These are domains, right?
and those are the domain of each of them.
Oh, so the x value on the left.
Ah, you got it. So on the right, it's the part of the domain. So here's the deal. Do any of those domains overlap? Nope, they don't. Look at this.
No, they don't.
They don't at all. You see this? And x is greater than 3. Do any of those overlap at all?
So none of them intercept.
None of them have the same vertical intersection, right? That no vertical line. This is still a function. So can you graph each of those 3 functions? What type of function is this right here? Linear. What type of function is this? What type of function is this? Linear. Can you graph those? Sure. Now, you only keep, Hannah, the part of the function. You keep this function for that part, this function for this part, and this function for that part. That's it. You erase the rest. So any vertical line you draw. So let's do the first part here. Negative x minus 4. What's the slope of that function?
-1.
-1. Here's -4, right? We're going to graph this. It crosses at -4 here. So here's this function, right? What's the domain of that function as I drew it? All real numbers, right? I didn't eliminate anything, right? But what do we want the domain to be?
Oh.
X less than -3. So where's -3? -3 is right about, I don't know, here, right? So we go down to there, and what do we do to the rest of that right there? You like the sound effects? I do. There we go. You see that? Is it an open dot or a closed dot? Closed dot because it gets to 3, right?
Okay.
And then you do the rest like that. One of them is going to be parabola facing down. You piece it together. This is a piecewise function, so it has to pass the vertical line test. How many people have dealt with piecewise functions before? A few of you? Now that you see it? Yeah, it's okay if you haven't, because it's not something you have to have covered before. It's totally fine. So do you think you can attack this and produce some good results for tomorrow? So the basic idea here, let me just paste this in for you so you have it here. Your homework for tonight, just so you have this, is this. Ah. You have to see me mess up while using the tablet. It's okay.
It says do as much as you can.
Yeah, so if you hit a wall on one of these, please stop. On anything on the homework, if you hit a wall, stop. I want you to make a legitimate try, but I don't want you to sit there and come in and say, I spent an hour and a half, I couldn't do anything. If you couldn't do anything, stop after 5 minutes and come in and ask questions, okay? Or call me or email it to me.
What's standard form?
What is standard form? Of a line?
That's the one with
Yeah.
This is your homework, ready? Look it up. Wikipedia is your friend. Yes.
Steven, why is your email there?
That is not my email. So, if you don't remember anything from this class, remember this. This right here is where all the notes are going. This right here, anything that touches the board gets posted as a PDF. For example, this is what the web page looks like. What block are we? E-block. If you click on E-block here, I'm going to open it in a new tab. You get a folder that looks like this. If you go in Daily Notes, you will see the notes from 2 days ago. So, in about 20 minutes, I'll put the notes up there from today. Got it? So anything that's put up there, you're going to have a copy of it. Do you feel as though you know what to do for tomorrow? Okay, so please put everything away. Math contest time.